So hello everyone, good afternoon. I welcome you all for this doubts or problem solving session of Advanced Geomatics Engineering for week 3. We'll wait for a couple of minutes. So if someone is joining, they can join and then we will start after 2-3 minutes. So I think we can start now. So hello everyone, once again welcome you all for this problem solving session of Advanced Geomatics Engineering for week 3. In this particular problem solving session, we will look upon some of the concepts related to the parallax and the height determination using the parallax method, and some concepts regarding to the photogrammetry, like how we can construct the what is parallax, how we can construct the stereoscope images. Yeah. Hi Shubham. Good evening. So I will repeat once again. So in welcome this doubt session of week 3, where we are going to discuss some numericals about the parallax method and how we can determine the height using parallax method, slopes method, and other methods which we haven't covered in the last few classes. And apart from that, we will see some of the terminologies regarding to this stereoscopy images, stereoscopy visions, and how we can use that for the different applications. So my name is Hiren Solanki. I am a PhD scholar in the Department of Earth Sciences at IIT Gandhinagar, and I will be conducting this problem solving sessions every Saturday, 3 p.m. to 5 p.m. You can, if you log out somewhere from the meeting, you can join again using this link, which is shared with you in your classroom or NPTEL class session and classrooms or channels. So we'll start with the first few questions. So our first question is, what is the primary purpose of triangulation in photogrammetry? So if someone wants to answer it. Yes, so you are right. So what do we mean by triangulation means? Triangulation means like we need like just working with 3 points where the location or data about 2 points are already known, or we can say the line connecting between these 2 points are known, and using that line and angles with respect to third point, we will find out the dimensions or distance for the third point. So basically what I'm saying is, in triangulation, let's say this is the known point which we know and which we will term as A and B. So we know the distance between A and B. Now let's take another point C, for which we don't know what is the distance. So for point C, for which we don't know the distance. So what we will do here is that we will construct the angles. So this angle, let's say we will name it as alpha, and then this angle as a beta, and then we will use trigonometry and we will find out the distance between point A, B, and C, like that. So we know this distance d in triangulation. So basically when the data related to 2 points are given and then using angles, you are calculating the distance between the with the reference to third point. So that is triangulations. So in case of photogrammetry, we use one point in one image and another point into another image. Then we intersect with the common point which is available in both the image and we find the distance with respect to that point. Now the next question is, what is the minimum forward overlap required between two successive photographs to form a stereo pair? Yes. So there's no doubt in this. So I will go ahead. The next question, which of the following is not a requirement for stereoscopic vision? Okay. Yes, yes, exactly. So the time should be similar, kind of. It has some of the delay in like fraction of minutes or seconds, but not much, because if that is the case, then we will have some different sunlights or different sun angle. Because of that, it will not help us to make the stereoscopic vision. So that statement is not true. Rest of the statements, like both photographs should have same scale, then and then we can find out the corresponding 3D difference or 3D elevations. Otherwise, it will not be possible. Parallax should be present. So that is also true, because if the images are vertical, then we will not have any parallax, and because of that, we will not have any height measurements. Also, we do not have any relief in that case. And the third, like D option, is the brightness of both photographs should be similar. So it should be similar only, then and then we will able to find out the 3D reconstruction, 3D perception. Otherwise, if some photo is taken during the daytime at around, let's say, 10 a.m. and one is around 4 p.m., the shadows will be different for both the objects, and because of that, it will create any issues in interpreting line. Then the next questions are, the key advantage of using stereoscopic images is, okay, so we'll decode one by one. The first one is allows precise measurement of spectral property of an object. So that is not right, because it will give us the idea about spatial property, length, width, or height, or volume, area, like that. Not the spectral property. So the option A is wrong because of that reason. Then we have provides a wider field of view as compared to the other imaging techniques. So that is all true, because we can keep two photos together and we can use the stereoscopic devices to measure the stereoscopic views, and then at the end 3D perception enables accurate determination of flying height. So that is not true, because we need flying height to find out the, because we are not finding flight height, rather than we are finding the height of the terrain or height of the elevations of the given point. And is the depth perception for 3D interpretation. So is it correct or not? So that is also correct. But now can we go back and check the, let's say, option B and option D. Now, which one? I think we should remove one, because see, if you see the option D closely, provides a wider field of view as compared to the other imaging techniques. So it doesn't give, I mean, see, if you are using drone or some other things, let's say in stereoscopic image also, we are restricted with view, because that aircraft or the drone or whatever the our device is, it will not able to capture the entire area. So because of that, the field of view is not that much high as compared to satellites or other thing. So because of that, B is not always true. If you compare the two different lens or stereoscopic device, such as lens stereo or mirror stereographs, then you can see the comparison wise, one has wider field of view compared to another, but in general it does not have much wider field of view. So we can here remove the point number B as well, just because of there is no clarity given in this question. So more or option D will be right. Which of the following is or are not an application of stereo models? A and D. So D is correct, but how A? Because what all we are discussing is the elevation difference or elevation. So ultimately, it will help us in volume computation. Yes, exactly. So how generally they use this thing on site? They have site some material stacked up like this in terms of this kind of bumps where the construction material is stacked over. It may be a sand, soil, or gravels or anything. So what they will do, they will find out the height of it. They know the base level, and then they know the shape of it, how whether it's a circular one or there's some other shape, and then they will find the corresponding volume. So they will able to see how much volume of any particular material is available on site. So option D is only the correct answer. Then the next one is how does an NL image work? These are the old methods of 3D perceptions. Yes. So have you seen this kind of cameras or lens? Okay. So if you have gone to some movie theater in your childhood, then you might have seen some kind of films with one with a red and one with a cyan, like two different contrasting colors. Or sometimes they, sorry, they used to give in newspaper as well. They will give some camera with the two different film that if you see the clips of newspaper, it will show you the 3D things within the newspaper or when you go for a movie. But nowadays they have changed this thing with the polarized cameras in the modern theaters. Okay, so the next one is which of the following are types of stereoscopes used in the photogrammetry? A, C, and D. Okay. A, C, D. So A and D is correct. C is not correct because polarized there is like that is another principle. I mean, which is not being used. There you are using vertical and horizontal transfer of receiver rays and all. So that is not perception for the stereoscopes. And if you see the option B and D, reflecting and mirror, both have same name only, like the same stereoscope but have different names. Like lens stereoscope, we can term it as a pocket stereoscope as well, whereas reflecting or mirror stereograph. So both have similar name only. So that's why option B and D are correct. Now, then the next question is what are the advantages of mirror stereoscope over a lens stereoscope? And I can reframe this question in a way like what are the advantage of pocket stereoscope over a mirror stereoscope? Or what are the advantage of mirror stereoscope over pocket stereoscope or reflecting stereoscopes over pocket stereoscope like that? So two different terminologies. Yes, true. So if we talk about lightweight and portable, then it is a lens stereoscope. Another three are true for mirror stereoscope, or we can say as a reflecting stereoscope. So option A, C, and D are correct here. Then the next one is, which of the following techniques is or are not useful for 3D visualization? Yes, true. Then the next one is, the average human eye base distance used in adjusting stereoscope is approximately how much in terms of mm? It says close 65 mm. So this is just a question. We go forward. This is numbers. Which base to height ratio is not effective for stereoscopic? So first let's discuss that how this will affect. I mean, what will happen if our base to height ratio is too much? So if base to height ratio is too much, it means what? Either your base, the difference between two exposure stations is too much, or else the height with reference to which you are taking the image is very less. So what will happen in that case if your height is very less? I mean, you also know that if the height is like terrain is more above, or the difference between height is too much, then it will have more parallax or more relief compared to if they like more parallax. So if it is high, then it's good. If it is less, then the parallax will be decreased. So that's why the high base to height ratio is not necessarily good. Similarly, like if the base station, if we like if one of the view like, so this is base, I think if you, I remember correctly, then this is the one station from where you are collecting image, and then we have another station from where you are collecting data or images. So the distance between this point and this point is known as a base, and then height will be the height from here. So this range is defined as a, can anyone know the range? So generally this range is defined as a zero point 0.2 to zero point 0.8 for the good stereoscopic viewing. If it is too much, then there will be less parallax. If it is too less, then it means that most of the time your, I think, base is very less, or your height is also very high. So you will not get the parallax in that sense. So generally the recommended values are between zero point 0.2 to zero point 0.8 for this ratio. And in some books you will find from zero point 0.3 to zero point 0.8 as well. So according to this, what should be your answer? So we can say that the D is our answer. Why? Because it is a very high compared to the accepted range values. So D will not provide us the effective stereoscopic viewing. Now the next question is, a pair of aerial photograph is taken with a height of 2500 meter above the ground level. The airbase between the two exposure station is 1000 meter with the overlap of 65 degree. Which of the following statement is true? So let's go one by one. Collected images are not suitable for stereoscopic viewing. So how will we decide that? As we discussed in the previous question, we have to find base to height ratio. If it is between zero point 0.2 to zero point 0.8, then it will be suitable for stereoscopic viewing. If it is not, then it is not suitable for stereoscopic viewing. So find out the base to height ratio here. How much it is? Yeah, so it is a suitable. So the option A is wrong. So the correct option A should be the collected images are suitable for the stereoscopic viewing. So because of that, the option A is wrong. Now the second one is it has base to height ratio of zero point 0.4. So as you calculated, that is right, which is not suitable for the stereoscopic viewing. So that is also wrong because zero point 0.4 is suitable. Now it has 65% overlap. Yes. Yes. So we need at least 60% overlap, but here it is given as a 65%, which is sounds good. If flying height will be decreased by 500 meter, then it will become suitable for stereoscopic viewing. So what about this state? So you decreased your flying height by 500. Yes. Okay. So here that you are right, but you have to focus more on the wordings which are given here. If flight height will be decreased by 500 meter, then it will become it means what, it was not suitable before, but after reducing it by 500 meter it will become suitable for stereoscopic viewing. So that option is wrong. Why? Because earlier also it is suitable. Yes. Any doubt, Shubham? Okay, so here you have to focus on wordings. It's written as it will become. So that is wrong because it is already suitable for stereoscopic. So if you will decrease the flying height, it will try to increase or decrease the base to height ratio. If you decrease more, then what will happen? Increasing. Yes. So inversely proportional. Yes. So the next question is filling the space stereoscope allows viewing of almost the entire overlap region using the mirrors and prism. Yes. So the next question is which of one of the following is true? Lens stereoscopes are suitable for viewing large photographs, not a single photograph. Pocket stereoscopes are economical over mirror stereoscopes. Mirror stereoscopes I have higher magnification than lens. Okay, so pocket is more economical, that is true, and mirror have higher magnification. That's okay. So how can we make it right? Yes, so either we have to write mirror reflecting. Hmm. Next, yes, true, true. So now let's go back to the next question, which is what is the primary function of Panam's functional fusion area in stereoscopy. So what might be the answer here? Okay, so here what they will do, they will correct multiple images of same thing if you have gone through the lecture. And then if your eyes will see, try to see from that image one 3D perception of it. So that's why they define the region where the brain fuses two slightly different images into 3D perception. So you can go through the notes, it will be there with some kind of animal image given into it. Yeah, so the next thing is you have to match the followings according to their terms and description given. So what should be your answer for this question? Yes. Okay, so the next question is what is the primary function of, okay, I think we have discussed this already. So the option correct answer is B here. The next one is which of the following statements about analgraphs are uh, anagrams are correct? So as you discussed earlier, the option A seems correct to me. Yes. Okay. But see, the option A and option C. Focus between option A and option C. Yeah. So I mean, the basic analogy here is you should have two contrasting color, complementary colors. And here in C also you can see the two spatial glasses with color filters. So it means two different colors only for viewing. So C will be same as A only if you see in terms of how complementary colors class. And option D, they cannot be used for DEM extraction, so that is wrong, but it can be used as a DEM extraction. The next one is aerial photogrammetry mission has a flying height of 4,000 meter and an airbase of 500 meter. Which of the conclusions are not correct? These one are. Mhm. Yes, yes, take your time. Others can also try to do the calculations. Yes, so the option would be right. You might have plugged the formula differently instead of yes. If an option if B is true, then C will be automatically go wrong. And current base to height ratio is right or wrong. Okay. Okay. So the next question is what is a parallax in photogrammetry? Yes. Next one, what causes the relief displacement? Okay. So camera tilt will not cause. Hmm? Yes. True. True. So only option B is correct here. Then the 22 number when your y parallax is 0. So what is a y parallax first of all? Yes. So when we talk about x parallax, yes. Okay. But I think if flying height are different, then the parallax will create because eventually it will be two different positions. So what is the definition is parallax is there should be a shift in object position with two photographs minimum. So object shifts are happening in Y, let's say if we are keeping our heights different, then object will also looks like moving or they have some kind of, we can feel that. So if but your height is at same level, then you will not feel the change in that thing. So that's why when the Y is 0, the flying height will be the same. Then you have when flying heights are different, so that is not right because like higher the flying height have higher parallax, and when there is a camera tilt, so if it is tilt, then also the parallax will be 0. The next one is x parallax is measured. True. 1024. Which of the following statement about parallax is true? Hmm. Is it right? Just check, just point it now. Like see, like this, draw a terrain, and then you are taking, let's say, 2 points. One is at low elevation, let's name it as A, and one it's a B, name it as a B. Now let's say this is our satellite, it will capture the object. Yes, okay, yeah. And then you will keep it here, and then you will find it. So the difference will be like high if the elevation, like this parallax will be very high because it will go like this in this case. Okay, so it will be very high if the y like greater for the high points and for lower points it's less. Sorry. Now let's go to the shadow formula. So what is the correct expression for shadow formula? So shadow it means that if you have a pole, L by 10 alpha. Yes. So it will be like this. Let's say this is a door or building, whatever it might be, and then we draw a shadow from this like post. So this is the like L is the shadow length and the angle of inclination. So angle of inclination is this much, which might be anything, and then your shadow length. The shadow I'm considering the full shadow right now. So now what we can do is we can apply a simple trigonometry here. So what we can do is 10 alpha is equal to height of the lamp divided by the distance between these two, which will become the distance AB. So if you want to find AB, then it will be equal to h upon your 10 alpha, or h upon AB. AB means this is the length. So you can say the height is equal to L 10 alpha. So option number B. Check it out. Okay. So the next one is which condition is not suitable for shadow method. So where which cases shadow method is not applicable. Okay. Okay. So these two are the right answer. Okay. Now coming to the next question. Relief displacement formula uses which formula? This we have already solved using this we examples in the last class. Yes, yes. Hmm. Early morning, if you see shadow will not be proper. Like the sun angle, it is at horizon only. It's just raising up. But the problem is that shadow will be like mixture of lots of things because the horizon is near to the horizon. That's why it will not give us the proper answer. That's why it is recommended to take the shadows after 10 a.m. time or that time when we have proper shadow length. Because what will happen, like your shadow length will be too less than in that case. Because if we take 10 alpha, then what will happen in 10 alpha? Because your angle is very less, so it will become very like 10 alpha is sine alpha by alpha, so it will become near to the zero. So you will not get any height. Like in few terms in terms of mathematics. Got my point? Okay. Yeah. So the next question, relief displacement formula uses. Yes. So option number A is right answer here. The next one, what is the most accurate method for height determination? So I think we'll not spend. It's a parallax method. Now the next question is, which data is not needed for parallax method? So you know which of the following it looks bit odd to you when we are talking about parallax method. So do you need shadow in parallax method? Because shadow is altogether a different method. So shadow is not necessary in this parallax method, and that's why our correct answer will be shadow, sorry. So shadow length will be our correct answer. Now the next question is, which factor does not cause height computational errors? So the first thing is paper photo shrinkage. If shrinkage will happen in a map or in a photo which you will take, then yes. So if it is proper, then it means what? That it will give no errors. Okay, if it is proper. So that option is our answer because it will not produce any error. If it is proper, then it will not produce any errors, basically. Then the next one is what if affects relief displacement's accuracy. Yes, that is correct. What about other options? Yes. Then yes, it's true. So all of the above will be your final answer here. Next is numerical, which is on finding the height using the parallax equation. So an object has a parallax difference dp of 12 mm at the absolute parallax p of 60 mm and the flying height of 3000 meter. So what will be the height of the object? So first of all, which formula will you use here? Yes. So what is that formula? Can you tell me? Yes. Fine, no issues. So we'll write down the formula. So H will be given by dB by P. So dP it means the parallax difference then divided by P, which is your absolute parallax, and then into you have your height, capital H. So now plug the value into this. What will be your answer? So if we put everything here, we will end up with, well, yes, yes, right. So 12 by 60, it will be 5, and then we will get 3000 by 5 will become the 600 meter. The next question is, if the x coordinate of a point on the left side of photograph in one first quadrant is 19.3% and the x coordinate on the right hand side photograph is in second quadrant and 13.74 centimeter. What will be the absolute parallax in this situation? So please look into the details which is given to you, such as the quadrants and the values. So the absolute parallax will be the difference of two parallax. So here, if we thought in terms of quadrants, so for the first, you can say the for first image or the image on left hand side. So you have these two images, left side image and right side image. So in this image, you are having this in the first quadrant, which will be somewhere here, and that is 19.3. Now we will take the another one, which is in right side photograph, and that is in second quadrant. So the value is given to 13.74. Now to find out the absolute parallax, what we have to do is we have to just deduct 19.3 or what? Yes, so it will become like negative, negative, positive, and that's why subtraction, it will become the addition, and then it will become 33, like 19.3 plus 13.74, it will be 33.0. Now the next question is, an aerial survey is conducted with a flying height of 2000 meter above mean sea level. The baseline distance, the distance between the two photographic stations basically, is given as a B, which is around 20 meters. The focal length of the camera is 15 mm. So the x parallax is given as a 0.1 mm over 1 centimeter. So what will be the height of object? Yes. Question? Is it covering question or drawing? No, no, drawing. I'm not drawing. It just happened by mistake. I have not drawn anything. It just happened by mistake, I guess. I will remove that. Okay, so height is given, base this line distance is given, uh, between two photographs, focal length is given, and then parallax is given. So here to calculate the H, we have another formula in which you can have the like simulation of all these variables, in which is given by the parallax is equal to BF divided by H minus capital H. So in here we have already B, which is 20 meter. We have F, which is 50 mm. We have capital H, which is 2000 meter, and P, which is zero point 0.1 centimeter. So plug everything into this equation and find out the small h, which is the height between these two points. Please be aware about the unit conversion, as some of units are given in centimeters, some in mm, and some in meters. Okay, so what is happening is one aerial survey is conducted with a flying height. So here this is the ground and this is the line from where the aircraft is moving, and it is moving at 2000 meter above this ground. So this distance is 2000 meter above mean sea level. Now the baseline distance B between two photographs, it means we can either represent it as the this image which is taken when we called it as a exposure station, distance between exposure stations, which we can define with B, which is given as a 20 meter, and then its measure is so 20 meter, and if the local length of the focal length of the camera, it means the camera is mounted over here, so it will get this much value. So the focal length of this camera is also given, which is 0.1 centimeter. Now you have to find out the height of the objects between these 2 points, like the height of H between these 2 points will be. So basically here we have to find out the small h. So the what is the parallax here is 0.1 by 0.1 centimeter. So we can write it as a 0.1 by 100. Then B is given as a 20. Then we have our F, which is 50. So 50 by 1000 as it is in meter. And then 20 meter we have. And then what we have else is H minus R. So H will be 2000. Minus H, that we don't know. That we have to find out. P1 is already also given 0.1. So I think everything is there. And if you do the calculation, you will end up with how much answer. Can anyone do the calculation? Yes, yes. So this I think we can remove directly 1 by 1000. Here 2000 minus h, and then this will become 1000. So if you do this simple mathematics, then you will end up with h is equal to 1000. Correct? Any doubt? Okay, then we'll go for which of the following height measurement methods is much more accurate and reliable. Yes. So option C is right. The next one is find the differential parallax between the top and bottom of the tree. So differential is just you have to take the difference between these two. So 15.2 minus 13.2, 13 sorry 13.5. How much it will be? So anyone is doing it? Yes. No, no, no. Because here directly the parallax is given and no quadrants are defined. So you have to use the direct. So basically 15.2 minus 13.5. If you do, you will get around 1.7. So 15.2 minus 13.5. The next question is a pair of overlapping vertical photographs were taken from a flying height of 1230 meters above sea level with a camera having a focal length of 152.4 mm. The distance between the consecutive exposure station, it means your B, is 350 meters. The parallax bar reading on a point A on the photograph is observed as a 10.06 mm. The parallax bar constant for this setup is given as 80.71 mm, and the elevation of the point A above sea level is found to be how much? So I think you have been given a lot of thing here, and we will start with a very basic fundamental formula, which is our formula which we used in the previous question, which is your polarization is equal to BF divided by capital H minus H. And if you change the sign, it will look like this. So now let's see one by one which of the things is available to us. Capital H, which is 1230 meter above sea level, that is given to us. B, B What is B? Here is the difference between two exposure stations, which is 350. So that is also given. So B is 350 given. F is already 10.96 is given. And this other things you have to write if you need it. So parallax it's not given. So that we can calculate using the parallax bar constant C, which is equal to the x parallax of A minus parallax bar reading at A. So these are the kind of tables or charts. So you have to go and search for parallax calculations, and then you have to see the set variant equations. Then go through like these things, how to calculate actual sweetness and all. So using this, you will get this. It formulation like parallax will be of A will be 80.71 plus 10.96, which is equal to 91.67. So now after plugging the value of H here, it will become 648.13 meter. So it's a very simple, but you just have to juggle with the different terminologies as well as concepts to find out the parallax of X. Yes, okay. Yes. So here it's given the parallax bar constant, and so that is equal to X parallax of A minus reading at A. So reading at A is like it's like vernier caliper thing. So we'll take a reading at A, which will be like full reading, and then we will measure what is happening in the parallax bar. So that we will either deduct or add depending on the error with reference to some benchmark point which we have already made here. Got it? If not, I will describe some with some figures in your annotated file, so you can look into there as well. Now I think next question is calculate the height of the lamp post for which the absolute parallax is 30 mm, considering the flying height of 1200 meter, airbase is 600 meter, and focal length of 0.1 to 150. So it's the same as previous question. H is equal to H minus BF upon P. So apply that formula and find out the height. H is equal to H minus BF BF upon P. So parallax is given, uh, this F is given, this B is given, and then capital H is given. So you can find out easily what is the H. Can you put? So it will give you a practice. So are you getting something like this? So any answer for this? You can keep everything into meter. So in that case, I think we can convert this focal length into meter. Yes. Thanks for this. And parallax also is 30. So like 30 also we will do. So basically this is already written here. So 30 by 1000. Okay, so give the simplifications and you will end up with some answer around 1197 meters. So I think now you can do this question later on. Yes, yes, it's the right answer. Right. The next question is, what is the primary difference between planimetric and topography? So let's start with option number one. Planimetric map shows 3D features, while topographic map shows. Yes, so you are right. Option B is correct. Next is, which of the following data is not input for DEM data? Yes. Next, which of the following is not an application of DEM? Yes. And which of the following is true here? Yes. Option A. So DTM generally inputs linear features. So if you interpolate those things, you can create the DEM. But vice versa is not true. If you have DTM, you cannot construct the like. If you have DTM, then you can construct the DEM. But vice versa, if you have DEM, then you cannot construct the DTM or DSM. So now the next question is, which of the following is true? Is or are? Maybe one more than one is also correct. Okay. It is not an option. So what will be the option here? Let's say like you have near. Yes, yes, true. Now let's go to the next one. Which of the following statement is true about tin data, which is a triangular irregular network, is incorrect? So that is incorrect. It should be irregular network, so it should not be equally spaced. Anything else is there? I think B only. The next thing is which of the following is not a free or open source DM data? Cartoset is provided by ISRO and that is a free of cost data which you can download from Google site as well. Option D, AW3. Now, which of the following factor does not significantly influence the quality of DEM? Hmm. Because color will not make any sense. Like it just show that whether it's a high elevation or low elevation, but it will not affect the like preciseness or the quality of it. The next one is which of the following contour presents pattern represents a hill. So if you have hill, how does the contour of hill will look like? Then what will be the next one? V-shaped contour will represent which kind of feature? Which one? The correct answer is valley. So valley will be U, or sorry, V, and then ridge will be U. Yes, yes. Or no. No, no, no. The option A, 47, A is only correct, and then 48, valley. Yeah, I think we can move to next one. Two contour lines of different elevations unite to form one line only in the case of. Yes, right. Next one is which of the following best represents a lake on a contour map. Okay, increasing value, inward, outward, which option? Option number. So, so let's take a lake. So let's take a lake like this. Okay, now if we plot the contour of it, it will look like this. Okay, and then what will happen here? Here the elevation will be very high. Let's name it as a 50. Then if we consider the contour interval of 10, then it will be 40. Then it will be 30. Then it will be 20. So here what is happening in terms of leg? If you are going inwards, the elevation is increasing or decreasing? C. Anything else? C. And in terms of option A and B, can you see something? Closed. Okay. And if I change the in terms of lake to hill, then what will be the case? Okay, so be aware about these things. Now the next one is what is the key contour characteristics of flat or gentle or sloping ground? Yes. Now in the following image, cases, contour line of different elevation can intersect. Yes, true. Okay. So any doubt like what we covered today is regarding this parallax method and then digital photogrammetry and then something about DEM and all. So any doubt till now? Okay, so what we will do now is I think we are remaining with one topic in which I will just show you how you can construct a 3D model using 2D images which you captured by drone or your phones. So today most of the people are not here and we also don't have, I think we need 1 hour for that. So we will not do that today. And the next topic, which is starting in this last week after this, is remote sensing. So, have you gone through the videos related to remote sensing? Yes, week 4 content. Okay. And in week three, the rest of the videos, I think have you gone through it? Okay. So I think if you have not gone through it, so what we can discuss some basic terminologies related to remote sensing. And one of the thing like which we have talked about DM data a lot in this class. So what kind of products are available, which we can download and how we can visualize them. So we can see these two things in today's class now. So let's get started. First, I will show you like how we can download the different DM datas. So if you have a laptop, you can search for the open topography site. So are you able to see my screen? Okay, fine. So if you open this open topography site and then go into it, so this site has lots of digital elevation model datasets. They might captured using satellites or drone or some lidar surveys. So it has a combination of multiple data sources for various parts of the world, which is open source for all. So if you want to search any data over here, you can go to data and then go to the data catalog. So it will show you all the database which is available in this particular website. Now, once you go here, then after you can see here there is three different tabs: global and regional DEM, high resolution topography, and community contributed. So the first one is global and regional DEM. It means it will cover the entire world or some bigger states or a part of world. So let's say this data set is for Canada. Then we are talking about SRTM data sets. So this is over here, SRTM data, shutter radar topography mission. And that is having three different parts. So if you see this GL3 data, then it is a SRTM 90-meter data. Similarly, if you see GL1, SRTM GL1, then it will be 30-meter data sets. And here you can see that there is a different terms, ellipsoid and geoid. So that we will discuss when we discuss the coordinate system. But these data are 30-meter data sets. Apart from that, this LOS data that is also available for world at 30 meter. That is provided by JAXA, which is from Japan Aerospace Exploration Agency. And another one SRTA, which is provided from the USGS. So if you scroll down, you can also see the regions in which data is available. So this is available for entire world. So you can see like this. Now, if you want to download the data for any of the region, then you go to the any part where you are interested. Let's say I am interested in this particular portion. So what I will do is, so here the options are given that if you want to download it, bulk download or ellipsoidal data, or you want to download through API. So I just want to download for small region, so I went here. Now select the region button is coming here. So once again, I will go zoom to some part. Let's say we'll try to capture this hill. And we will select the data region. Now it will automatically, you can also provide the latitude and longitude if you know the boundary of your area. Then after you just go down And then if you want to visualize this in the different terms, you can click on any of the option, such as let's say if we just want to visualize it as a hill shape. So you can directly download the image as well for those things. After selecting those things, you can provide your email ID, and then there is a more options also. So you can specify the title, so what you are doing. So I am doing PhD scholar, so I can do that. And description, if you want to put, you can put the description also, and then you can submit the request. So once you will submit the request, it will take some time. So basically it will vary upon the data which you have asked for, and then it will give you a download link. So, and whatever the other visualization parameter if you have selected, then it will show you. So now you can see this data sets link came. So I can click on the link and the data will start downloading into my system. And you can see it will look like this. So the data which we have downloaded, it will look like this, the hill shade part. So now if I want to visualize this data, what is the elevation range from what is the minimum to maximum elevation and all those things, then in that case I can use any GIS software such as ArcGIS or QGIS. So I have QGIS in my system, so I can just quickly show you how we can work with it. So I will open the QGIS version in my system. So once I will go through it, then I will go slowly after one more time, so that if you have any questions, you can ask. Yes, yes, you can. Yes. So what you are like, which city you are working on right now? Uttar Haryana. Okay, and what do you want to show in that? Hmm? Yes. So I will get back to you. I will just show this DM data and I will get back to your question. Okay. Uh, so once you download all the data sets, your GIS is open, you can extract the data. It will be in zip format. So extract the data and then you can just drag and drop the data sets here. So it will look like this. So now here you can see this image is black and white image. Okay, and we know that this is a DM data. And what does DM represent? This is digital elevation model. So it will represent the elevation values. Okay, so here on this side, if you can see my cursor, on the left hand side, you can see the name of the DEM and the values 173 and 996. It means if the value is high, it means the higher elevation. If it is less, then it is a lesser elevation. If it is black, okay. So now let's visualize it in more proper way. So I will just right click and go to properties. There I will go to symbology and I will try to change colors of it so that we can visualize it properly. So I think you can see it now properly that now my colors are like light blue to it's going white, and these are the highly elevated areas. Can you see this? Okay, so after that, if you want to see what is the resolution, like when we talk about this pixel, so if you zoom it, then you will see the pixels, and then you can measure the length of one pixel using this measure line. So you can see it's around 30 meters. So this pixel is 30-meter pixel. So one pixel by one pixel is 30 meter by 30 meter pixel. So 30 by 30 meter, you will get just one value. And if you want to analyze which value it is, you can just use this I button and you can click wherever you want, and you will get to know here that the elevation is 554. Here the elevation is 390. Here the elevation is 386. Here the elevation is 531. So like that you can analyze the elevation values as well. Okay. So this is like your DM data, how it will look like. Now let's see how other data will look like, or what kind of other data we have into that particular portal. So we'll go to data catalog one more time, and you can see here there is a data related to the Arctic DM which is available at 10-meter resolution. Okay, then we have this data for global ecosystem dynamic investigation. So this is gridded surface land surface matrix. So you can go and check out the data, which data is there, and then how much area it is covering, and what is the resolution of the data. So it is covering the entire world only, but at which resolution that you have to check. So this data sets is collected, funded by NASA only via mission. So this is the GD data sets, which is high resolution laser ranging observations of the 3D structure of Earth, giving precise measurements of forest canopy height, canopy vertical structure, and surface elevation of greatly advanced ability. Okay, so this will give us the forest canopy as well. So it is kind of DSM kind of thing. Thereafter, we have one more data sets, which is Copernicus data. Yes, yes. Yes. So you have to select the region that is you just have to drag and drop and you have to select the region. And if you know the actual lat long, then you can enter that lat long also. Show you. Uh, yes, yes. Okay, that is filled. Hillshade, slope. This is like for just visualization purpose. This DM is a raw data and everything can be derived using that data. But in this portal, they are all the doing all the computations to derive the shade, to derive slope, and they are giving it directly only. So if you don't want to do analysis, they will give it directly as an image format, as we got it here. Yes, so everything can be done in ArcGIS or QGIS as well. But this site gives additional options where you can do all those things inbuilt. So it's up to you, like what do you want? If for any reason, if you want slope, hillshade, everything, you can just do it here only. But you cannot process it. It's just image. Okay, if you want to do further analysis, like give me the pixels with high elevation values or pixel with more than 2000-meter elevation, then you cannot do that because it's just image, not a data. Got my point? Okay. So here also Copernicus data is also available for 30 meter and 90 meter. And here you can see this Copernicus DEM is a digital surface model, not the DTM or DEM. It's a DSM. It means it includes the building, infrastructure and vegetation as well. And this DSM is derived from an edited DSM, which is World DA. Basically, this data is covering the entire surface of the earth, which includes the building, forest cover, infrastructure or vegetations, everything. But wherever, if you see the previous data SRTM, it is DEM data, in which it will give the bare surface elevation only. So depending on which data you want, you can select the region and then do the analysis. Now, let's say if we see here in Bangalore or something, now there are so many buildings. So buildings height will also come into picture, and because of that elevation will increase. Okay. Now what else is there in this data? So like this Copernicus, SRTM, there are some other DMs are also available, such as NASA DEM. Then this is the bathymetry, which is for bottom surface of the ocean. Then this global multi-resolution topography GMRT dataset is also there. LOS data is also there. GD data is also there. So all these are openly available for most of the world part. And then if you need high resolution data. Now these are the data how they have got is let's say some researchers is doing work in some of the XYZ area, and then they uploaded their data into this particular website. So this will be like very high resolution data sets captured using drone or LiDAR surveys. So I think what we can do is we can just download a small portion of this data sets so we can see that how does it look like basically. So this point cloud data I think we can download, which is like South Land, New Zealand. So this is collected using airborne LiDAR data. And this is the data is collected between 15th of December 2020 to 30th January 2024. So this data is for this much region only, as it is very high resolution data. They will not give us the like full. Okay. Then after you have to see here tile index in shapefile format. So we'll start downloading the data. So point cloud data or bulk download, what kind of downloads you want to do. So point cloud data, if you want to see, again I will select my region. So what I will do, I will just zoom it. So basically, let's say we will select this part, and this is, you can see, this is which kind of map, topographic map or planimetric map. The map which you are looking here. Yes, because yeah, exactly. So we can just select a very small portion here because otherwise the data volume will become too much. So I selected the area. Okay, still this area is too big. So we will select a very small area. So here you will see the notification. The selected area is too much. For that we have to log in and then download. So if you don't want to do that, just select another region, small region. So this small region also has how many? It's very having too many points. Similarly, here see you have the options like custom DM generation. So here it is generating the team data, which we discussed in the MCQs as well. Triangular irregular network. So this visualization, if you want to generate, you can. Otherwise, it's not mandatory. You give your email address and then submit a request. So meanwhile, it takes time. I will just I think it's so right now we haven't given any option regarding the plane or slope or any other thing, so it will not produce any of those things. So yes, it's downloaded and you can see the size is DM data is generated. So you can see this data will look like this and we'll change the symbology again. So you can see now how does it look like. And if we zoom in further to the pixel level scale, now you can see 1 pixel, you can see the 1 pixel boundaries. And if we measure this boundary now, let's see. So you can see it's this pixel is around zero point 0.9 or you can see it's a 1 meter pixel. So earlier it's like 30 meter pixel and now it is a 1 meter pixel. So you can see like 1 pixel get converted into 30 by 30 meter. So 30 by 30 it means you have 900 pixels. Okay. It's very high resolution data and you can see now everything and if you have 3D then you can just I will just show you how to do that. I will teach you in some other labs. I will just right now give a glimpse. In detail we will discuss in some of the other labs. So I will try to see these things in a 3D so that we can visualize it. So you can open this 3D map view in QGIS or ArcGIS, whatever you have. And then after you can set the terrain. Then here, there you go. Can you see this now? How does it look like? So you can see now how the small details it is capturing, how the hills are there, and how the water will flow from where the water is coming. So all those things you can do analysis now onwards. So I think this thing in detail we will learn as well as multiple labs. So this is like how you can use DM for various purposes and various data you can download from these sites. And if you use QGIS or RGS, you can visualize those data there. Now coming back to your question, you have Haryana's file, I guess, Rohtak, I guess. If I'm, you have the file of Haryana, I guess. Is it right? Okay, so you can go to any of the city and what do you want to do further? So something like this. Okay, so for that, I mean, you if you use any of the software, QGIS or RGS, you can load a base map, which will give you the different buildings or different amenities which is available. Okay, so you have to use this base map feature. Base map is nothing like what you have in your Google Maps. When you open a Google Maps, there is just a plain view, which is a gray color map. And then if you go to satellite mode, then you have your satellite view on. So are you sure this? So if you open this map, it will look like this. Your Google map, and then if you need anything like let's see Rakhi Gari, if you take this thing, this is Harappan town. So then you can just go to Google Maps with satellite view on, and then you can do the zoom level too much, and then you can analyze the different buildings and all. So same thing you can do it in any of the tool as well. If you zoom in further, you can check out the different buildings and all. Apart from that, there are a couple of other base maps which are also available, which will directly give you the vector tiles, such as like this. So if you have this kind of net data, then it will give you just directly lines and all. So like this, the geometric boundaries. And the languages and everything will be depending on which region you are, it will change. So here if you go to Kshetra and all. So like this, you can see the extent of cities, and if you go further, you can see the different roads. And if you go further, you can see parks and all are there. River is flowing. You can see those things as well. So this is like very high resolution data as well. So it depends on which software you are using. You will get this option of base map, which you can load and then you can visualize. Any other thing? Okay. So any doubt in today's class? What we discussed is we discussed some of the questions related to the our parallax 3D imager, digital imageries and DEM. And then after we discussed about what are the different DEM products are available, whether it's a DEM or DSM or DTM or LiDAR data or drone data, how to download those data sets and how to visualize. So how to do it in software, it's not a part of this course, but if you are interested, I will show you. Just to drop me a mail or drop in discussion forum that can you please deliver it to us, then we will try to do that thing. Uh, Apart from that, any question in today's class? Okay, fine. So what we will do in next class is we are starting with the new theme, which is remote sensing, which is like measuring the uh, various events, phenomena without being in touch with the object. So basically, we are using satellite data sets, satellite images to measure different things such as rainfall, temperature, or ocean monitoring, or for mapping urban areas or snow lakes like glacier lakes, or so on and so forth. So how we can use different imagery for various purposes, and what are the different characteristics of those imageries, whether it's pixel size, which we term as a spatial resolution, temporal resolution, spectral resolutions, or radiometric resolutions. So what are the different terminologies? How does this satellite collects the data from Earth's surface, and from which pathways it will go, and how do we get the data at the end? So that we will discuss in next class, and questions on that. And if time permits, then we'll see some of the satellite imageries as well. So that's we are going to do in the next class. And any suggestion for the next class, if you have? Okay. Okay. So if no more questions are there, then I think we can close this session now. I think has not DAM, but 3D images will see like small models, because DAM we need drone data sets, which I don't have. So, and you might also not have. So we'll try to take phones, like photos through our mobile phones, and then after, like say if any bottle is there, so how to make a bottle 3D using like images from different angles. So I think that exercise we will do. Okay. Okay. So any other thing? Anyone else? So who else joined today's session? Can you introduce yourself? Okay, I think if not, then we can close this session now. Thank you for joining, and we will see you on next. Yes. Okay. So I think I just. So thank you for joining. We will see you in next Saturday with different topics. Yeah. Okay. Bye everyone. Okay. Bye bye. Have a nice day.